Hello guys, welcome back. In this video, I'll explain fine-tuning of an LLM or SLM using advanced SFT with LoRA approach with using unsloth. So what is this SFT, sir? SFT stands for Supervised Fine-Tuning Trainer. Why do we need this SFT? Nowadays, we have advanced approaches came into picture for fine-tuning a already trained or pre-trained model. So among them, this SFT is one of the efficient approach, that is supervised fine-tuning approach. There we will use a trainer as well as a configuration file by using this SFT approach, and we will train our model effectively. Like whatever we want to train. Let's say in my model supports multi-type, like it supports image generation as well as text generation. So among those two, I just want to train my model with some text data. So during that time, we can specify that details in this SFT trainer, like I want to train only text data, and I want to apply this training or fine tuning job to my attention layers only and text layers only. So those details we can able to mention using this advanced approach. I'll show you, or you can see that while writing the code. So what about this LoRa? While fine tuning a model, while fine tuning any model, you don't need to specify, or you don't need to take into consideration of all parameters. You just take low, that means less parameters, and you can take use of all the default parameters for better fine tuning. To set only the required or low parameters and make use of default parameters, you can use this LoRa approach. That means low rank adoption. Here we will provide R, that rank we will provide, and some more details we will provide. And if we use this configuration LoRa type configuration while fine tuning, it will take use of all the default configurations for fine tuning except the low parameters, that means very less parameters that we need to specify here. Now to do this, that is this LLM fine tuning only using a LoRa configurations, transformers is supporting. But what I'm expecting, in addition to this LoRa configurations, I want to make use of this SFT, that is supervised fine tuning approach. So that advanced approach along with this LoRa configuration is supporting by unsloth library. So that's why we are using this to fine tune some SLM or LLMs. So what is this unsloth? It's a library which is providing us advanced approaches or advanced methods in order to fine tune our model. So in order to use advanced approaches, we need this unsloth, right? Yes. So let's first install that unsloth library. Now to install the unsloth library, these are the commands in order to do that. Currently, I'm using Google Colab. For fine tuning our model or any SLM or LLM, we need a GPU. That GPU is freely available in multiple sources. Like in Google Colab, we have that free GPU availability under this runtime sessions. You can see T4 GPU availability is there. I'm just using that. Where Kaggle notebooks also supporting you for free GPU for 30 hours, whereas this Colab is supporting for 10 hours per week. That Kaggle also supporting per week 30 hours. For now, I feel this Google Notebook is a bit better, so that's why I'm just taking it into consideration for fine tuning. And now It's your choice in order to choose whatever the GPU option, like which platform you want to work with. The code that I explain will work on both platforms. That is, irrespective of platform, I'll explain this code. Okay, let's do this fine tuning job on this Google Colab using this approach. For this, we need this unsloth, right? Yes. So, in order to install unsloth, if you are using not, or you can say you are not doing parallelly with me in your Colab, then you can make use of this command for installing the unsloth library. Otherwise, you can use this command. That means if you are doing parallelly in Google Colab along with me, you can use these commands in order to install the unsloth. So I'm just shift and entering so that my runtime will start. Before that, I'll make a copy of it. Yeah. So I'm opening the notebook in a new tab. So now I'm just running it. So you can see already in release note, there will be some already pre-installed libraries are available. So why I'm using this command in Google Colab and why you are using this command in other platforms like in local VM or in cloud virtual machines, why we need to take this, or why in Google Colab we need to take this command. The reason is that in Google Colab already there will be some packages already pre-installed. So in order to not disturb them and in order to make the installation smoothly and without overriding already available packages, what we are doing is we are just downloading or installing, you can see, whatever the required other libraries other than present libraries. And we are even not installing the dependencies in order to overcome the conflicts which are happened if any dependencies got installed. Already some dependencies are there, right? Already pre-installed. Those dependencies do not conflict with whatever the dependencies that we are installing. So that's why we are not installing any dependencies. For unsloth, whatever the straight and forward required dependencies are there, only those we are installing by excluding whatever the already installed packages present in the Google Colab. Why this percentile capture? So this percentile capture is used to hide, or you can say to not to show the output. Like for installation, there will be a lot of commands will be shown here, or lot of output will be shown here. Like you may get some mistakes, or you may get unexpected errors. So like that, and installation process also will be seen in the output. In order to overcome that, we'll use this percentile capture command. So now our unsloth got installed successfully. So how to verify that unsloth got installed? To check unsloth got installed or not, let's import that unsloth library. So if I can able to import it and if I not get any error, then I can say my unsloth got installed in it. If I got any errors, then I can say unsloth is not successfully installed. You can see, so it's just loading. That means there is nothing error while installation in it in this Google Colab. And from these output, we can able to understood that the training or fine tuning will be 2 times faster than as usual fine tuning. If we make use of this unsloth in order to fine tuning. Now, since our library got available to us, I want to fine tune a model, right? So in order to fine tune a model, what we require, we first take the model or load the model, and what we need, we need some data set as well. Then by using that data set, we will train our model. So let's check with the available models. Where you can find is inside Hugging Face. You can search for this unsloth. If you search for this unsloth, then it will open any one of the model. You just open their page. So in their page, you can see the models. Totally 7-10 models are there. I'm just expanding it. So these many models are supported for fine tuning using the unsloth library. Okay. So now what I want to train is advanced gamma models. I want to train. So in gamma also, yeah, 91 models are there. So in this, let's take gamma 3 models. In gamma 3 also 51 models are there. So let's take a small SLM like 4 billion model. So in this also 15 variants are there. Among this, so I want to take this. That is a gamma 3 4B IT model I want to take. So in this also totally 12 models are there. I just taking the base model. I'm just selecting it and copying the model name. Now let's try to load that model using unsloth as well as the model related tokenizer also we need because in order to pass the input or get the output, we need the tokenizer to convert the given input or data into the format that model is expecting. First, let's import fast model. Where it is present is from unsloth. Let's import the fast model. Why do we require this fast model? Our need is to load the model as well as the tokenizer, right? In order to load them, we require this fast model that is present in this unsloth. So that's why I just imported this fast model. And in this fast model, we have this get, or in this we have from pre-trained method is there. By using that, we can able to load any models. By default, you can say this model is taking like llama 3.2 11 billion vision INF model is taking. But what model I want to take, that model name I need to provide. So I just copied the model name, right? I'm just pasting that here. That is unsloth gamma 3 4B IT. Then we need to provide max sequence length as well. So here in place of this model name, other than this unsloth gamma 4B IT, whatever the models that you have seen in the Hugging Face under this unsloth account, you can see you have 7-10 models are there totally. You can use any one of the model and then you can able to fine tune that model with your domain specific or account specific or company specific data. Okay, then what I need to choose is, so what is the length of context? So what is the sequence length, max sequence length? This you need to take into consideration of the model architecture. Based on the model architecture, you need to choose. You can see by default also it is taking this max sequence length as 2048 because in background in their unsloth library they chosen the default parameter of the value as this. So I'm just taking that as the same. The understanding of this max sequence length is also very important. The reason is that it defines the context window length of the data that our model is going to process. If we choose this less, then it will work only for lesser size input and less size output. If we choose an large, then it can able to process long context windows as well. So I'll explain it with an example. If we take an example like I want to generate a simple print hello world program. So for that, less max sequence length is sufficient. If I ask a question like I want some Python code for this requirement, then it can generate with the max sequence length is less. So in the same time, if I provide a large 1,000 lines of code to my model as an input and ask it to, so what this code is, so like that, if I ask, then what happens is if the length of tokens are exceeded than the max sequence length, then my model cannot able to process it. So during that time, we require large sequence length models. So that you need to set it here. So in order to set it, you need to consider what model you are choosing and that model architecture. This max sequence length depends on that model architecture. So while designing the model, they have already preset the model related max sequence length based on the architecture. They use it for pre-training the model. So that only that max sequence length we can able to take. We cannot able to take more than the available models max context window. If we want like a high context window, then we need to create our own pre-trained model with whatever the expected max context window length, that much. Nowadays larger models are came, and even Gemma also support 128K tokens, that is a max window length. So that much of prompt or data you can able to process with that with that model. Like if you give a large 1,000 lines of code, and if you ask it to process it or generate an update of it, upgrade of that code, then what happens is it will check with like first it will convert that data into tokens, and the tokens length is less than the max window length like 128K of your both input as well as answer, then it can able to process and provide you the output. So that's the importance of this max sequence length. So for now, for this demo, I'm just moving on with the default parameters, that is 2048. Then, so coming to loading, now I want to use some advanced approach, like I want to do quantization, quantized model I want to take. For fine tuning, I want to take quantized model. It's not a normal LLM or SLM fine tuning, it's a quantization of LLM and SLM and then fine tuning that with advanced approaches. So this is also we're adding up. We can add up that here. That means, so in order to reduce the max memory that is consuming, currently I want to make use of 4-bit model by loading that in this. So in order to specify like load 4-bit model, then you need to specify it as true here. So this will load quantized model like 4-bit quantized model of this gamma 3 4B IT. And so if you want a 8-bit model, then specify 8-bit. Currently I'm providing it as false, so no need to specify it as well. And even fully fine tuning option is also available with this, but currently I don't want it, so that's why I'm providing false. And so some models like sometimes you can use the gated models for fine tuning. So during that time we need to specify the token, that is a hugging face token, we need to specify something like this. But so currently this gamma model that I'm using is not belongs to that, so that's why I'm just loading it directly. So where the quantization is happening here, the quantization is happening. Okay. So I'm just loading quantized 4-bit gamma 3 model. You can see the model is getting loading. Now the model is getting loading. Yeah, it's done. So it takes approximately 1 minute to load this model, that is a 4-bit model. quantized model. Now we just loaded a quantized model that is a 4-bit gamma. Since it's a 4-bit only, we can say it as a SLM. In place of it, you can make use of the available LLMs as well. Whereas max sequence length, in order to specify the context length. And so this is for quantization. And for fully fine tuning, you can even make use of this as true. Since our model got loaded successfully, let's test or let's verify whether our model is there working correctly or not by providing some input and getting some response from it. So in order to do that, let's create some user messages in the form of a list of sets. Like we need to provide two things like as a user, we need to provide the role and we need to provide what is the content that user is asking and what type of content that user is asking. Since it's a multi-modal, it has multiple types of contents, like right. Currently I'm providing some text type input, so I'm providing that a type, and the text also I'm specifying as like who. Mhm. Let's ask what is gamma 3. So this is the message I want to ask to my model. So in order to ask it, let's first tokenize this message. How to tokenize this message is using a tokenizer, whatever the tokenizer that we previously created here. Using that, apply the chat template to this message to make it suitable for taking it as an input to our model. And let's add generation prompt equals to true. This must be added for since we are generating that text. So let's use the model dot generate method and let's provide the input to it by using the tokenizer of this text I am passing, and return type I'm passing it as tensors, PyTorch tensors. I want the return type to CUDA memory. Then you can specify some other parameters like max sequence length. So those you can able to even specify. For you, I'm just showing that like max new tokens equals to for now just I just testing, so 64 tokens if I get then I just stopping the message. And here you can even specify temperature like one, and you can even specify other parameters like top p and top k also you can able to specify. And one more important point that I want to tell it here is if you are using unsloth, then these are the recommended parameters for top p, top k, and temperature to getting a better response. And currently I want to stream the output. I want to show you the streaming output. So that's why I'm providing the streamer. using a text streamer by providing the tokenizer whatever I created previously to it, and I'll skip the prompt. And where do I get this text streamer is from transformers. You can able to get this text streamer. So that's why I'm just importing it from there, and I'm just running this cell so that this model will generate me the response as well in a streamed format. The model is nothing but whatever the model that we just previously loaded that I'm using. So it's still working. Let's verify, do we get the output or not? Yeah, you can see. Okay, let me break it down. Gamma 3, it's a fascinating development. Yeah, so it can able to develop the output as well. That means we can say our model is working. So why the less output is getting? The reason is that max tokens equals to just 64. If I want more, then just increase the max tokens length, then it will increase you the output length. Like you can say max new tokens which are generating. So I can say from this our model is working well. Yeah, you can see our model got loaded successfully, and our tokenizer is also working since we tokenized it, and we tested our model as well. So till now you understood like installation of unsloth as well as loading the model as well as verifying whether the model is working or not. Now let's move to the next step. Okay, now let's move to the next step. Verification got done, like our model was loaded successfully. The next step is to add some parameters, like to update only small amount of or less amount of parameters. We are using LoRa adapters, and when loading our model. So how to load a model using a LoRa adapters? So fast model dot get PEFT, that is a parameter efficient fine tuning model from, so whatever the current model is there, using that model, and I'm providing a LoRa configurations like R is equals to 8 and LoRa related alpha, so it must be equals to R for better performance and results. So I'm just taking it as 8 again, and LoRa drop out. So it specifies which layers or how many layers you want to make drop out so that the knowledge related dependency will be reduced. So currently I did not drop out any layers, so or I did not drop out any knowledge, so that's why providing it as a 0, and I'm specifying a bias as none, and I'm also taking a random state of 3407. So along with this, I want to specify which layers I want to train and which modules I want to train for my model. So fine tune vision layers. Since I'm using only text data and I want to fine tune only text layers, I want to make it as false. And so those parameters we can able to specify here. Fine tune text, or you can say language layers equals to true. So in the same way, we need to specify two more details like fine tune attention layers attention modules equals to true in order to fine tune the attention for good GRPO, and for fine tune MLP modules as well we need to put it as a true. Yeah, now I'm just loading this LoRa adapter configurations to my model. Now the LoRa configuration is also loaded. It just take these parameters and make use of default parameters, then it will fine tune the model. Since our quantized LoRa configured model is readily available for us, now we'll focus on data to train this model. So what I need to focus on data, like what are the points that I need to fulfill. First thing, I need to take some data, and second thing, I need to convert that data into suitable format for fine tuning to this model. What data I need to take? Do I have any conversational data? I want to fine tune my model with some conversational data. If I ask some question, then it need to provide me some responses like that data I want. For now, for this demo, I'm just taking already available like Hugging Face free data set, that is a Mabalon Finetone data set. In this, if you observe, you can see this conversations are there with a human as well as a value is there. So after that, if you watch this, then you can find, yeah, and along with the GPT related response is there. Human question, like human and his question, GPT and that answer is there. Now I want to make use of this data set, like 100K records rows are there. I want to make use of this and fine tune my model. So let's load this data set. In order to load any data set from Hugging Face, you need to make use of this load data set method, and need to provide whatever the data set that you want, that name, and I want to split it into train. So that's why I'm splitting it and storing it in dataset variable. If I run this, obviously I'll get error because I haven't provided what is or load dataset is not imported or not defined. Where it is present is from datasets. This load dataset is there. So first I need to import this, then make load of my, you can say, dataset which is present in the Hugging Face model. If you want to load any dataset which is present in the Hugging Face model, then you also need to load the dataset like this using this method. Since I loaded my dataset, I want to standardize this or standardize this data format by using unsloth library. You can see standardized data formats method is suggesting for me for this data sets, and I just save the data set in this. This standardized data set is present in unsloth chart templates. I'm importing that from there and standardizing my dataset. I just loaded my dataset and then I standardized my dataset. Then what I need to do? I need to convert, right? I need to convert the dataset into suitable format for training. So in order to convert the dataset suitable format for training, we need to get the template of our model. So what is our model? Our model is Gamma 3 model. So let's get the template of it and let's make use of that and convert the dataset into suitable format. So in order to get the template, get chart template method is there. There we need to specify the tokenizer along with chart template, whatever we are expecting. Since I'm expecting MR3, I'm providing that. and I'm loading that tokenizer, final tokenizer for that with that chat template. So where do I get this get chat template? From unsloth itself, it is available. You need to import this get chat template from unsloth chat template. That chat template, this get chat template is available. Now I'm upgrading my tokenizer with the required model chat template. So now we have the chat template, like you can say the tokenizer chat template is available. Before converting our data set, let's check how the data set will be initially. So you can see conversations is there with a list of values, and you can see like a user related input value is there, plus role, that is assistant related value is there. So when this got changed, I'll show you that. So initially how the data was and how that was changed. So if you load the data set, initially the data set will contain from human and value is user, and from GPT the value is this. So like that the data will be. So if you want to see this in a data frame format, I just show you that as well. Let's see it in a data frame format by using pandas. So let's see. You can see conversations is there, source is there, score is there. So initially from human and value, and GPT and its value is there. Now I'm after standardizing, what happens is so it will be standardized, like these values will be changed from as well as human and value. These will be changed. If you see that output, I'm just pasting the same like data set of 0. You can see the content as well as a role. So previously what it was, from is there. Instead of from you have this role option, and instead of human you have this user option, and instead of value what you have this content option. Instead of yeah, so those will be updated, standardized. Now if we see in the form of data frame, it will be a bit more clear to you. Yeah, you can see the content as well as the value, and the content and the value. So I think it need to expand it in order to see these internal details, like instead of GPT assistant, and instead of from the role is there. So those things I hope you understood. After standardizing, then what we did is we just loaded the tokenizer with the chat template, and before applying the chat template we have seen how the data set will be, and let's print it in the form of the data frame as well. Then let's define some function in order to apply the chat template. So whenever this function receives an example, then that example will be applied for the chat template. Using tokenizer, I want to apply the chat template. Using tokenizer, I'm applying the chat template. For that example, conversations, you can see in this, only for these I want to apply. So that's why I'm providing conversations. I'm applying this chat template using the tokenizer and saving it in the text variable. And at last I want to return this in the form of a dictionary with a text as this text. Okay, so now I just defined my function in order to apply the chat templates. Example is not, it's an example. So whatever the thing that we define here, the same thing we need to provide here. Yeah, no error is there right now. Now let's map our data set. Dataset dot map of to what? To this function. What is the function name? Apply chat template in the form of a batched mode, and I need to assign the result to the data set. So the mapping is happening. So after the mapping is happening, we can able to observe the changes. Previously, we have conversations, source, score. In conversations also, we have only two values like user related values as well as user related content as well as assistant related content. Now let's see the data set of 0. In this, so under conversations, similar to previous, you have this content like user content is there as well as assistant content is there. So along with the three fields like conversation, role, source, and score, you have this text got added additionally. So if you want to see that change, previously we have only these three. Now I'm printing this. You can see this text got added. In this text, what are the things we have? Start of turn with the user turn got started and their message, user message. Where is it? Yeah, user message is there. So till where it was? You can observe that here, like here end of turn is there. So till here that user request or requested message is that, and from here the model related response is this all. So like that the data which we converted is we saved in this text field. If you want to see only the text field, then you can make use of a dataset of 0, and in that only text field I want. So you can see you can able to get that text field, only text field. Since our data set is ready and data processing is also done, let's train the model. So in order to train our model, first we need to create a trainer. As previously discussed, we are using the SFT trainer, that is a supervised fine-tuning trainer. In order to create this trainer and the configurations of that trainer, we have those already available in TRL. So what is this TRL, sir? This TRL is nothing but it's a transformers reinforcement learning library. So inside that we have these advanced methods, that is SFT trainer. And so for this trainer, in order to provide efficient configurations, we have this SFT config supporting this SFT trainer. Now let's create first this SFT configurations, and let's use those configurations in order to create this trainer. So in order to create this SFT config configurations, we'll make use of this SFT config. And in this SFT configurations, that is supervised fine tuning configurations, we must need to specify so dataset text field. So what is the dataset text field? That we need to specify. In the dataset, where my text fields are there, inside this text. So I am providing that text. And per device, we also need to specify what is the batch size for device, what is the train related batch size we are going to use for this training. Two I want to take. And what is the gradient accumulation steps? So that also we need to specify. Currently I'm taking it as a 4. And here we need to understood why do we use this gradient accumulation. The reason is that to mimic whatever the batch size is there, for that we need to use this gradient accumulation. Then we need to set warm up steps parameter as well. So currently I'm just taking it as a 5. And number of epochs. So that also we need to specify here. One I am setting for full training run. Currently, since it's an optional, I'm just hiding it or commenting this. And max steps you want to cover. I want to take 30 into consideration, so that's why I'm providing that. And learning rate. So how much speed or how much learning rate you want to put. So that I am providing here. That is 2e minus 4. That means reduce it to 2e for longer training runs. Then log steps we need to specify. And optimization. So this is important. Optimization. Which type of optimization technique that you use while training your model with the dataset that you given? Which type of optimization technique that you want to use? So for now, I'm just taking use of Adam W 8-bit I'm using. And so weight decay, it will be 0.01 I'm taking. And linear regression related scheduler type also we need to specify it as linear. And SCD, so by default I'm taking it as a 3704. Report to, currently it does not report to anything, so that's why I'm providing it as a none. Use this as a WAND, or etc. based on your requirement. Okay, so these are the configurations I'm specifying for the SFT. Then we need to define the trainer. How to define this trainer? In order to define this trainer, let's make use of this SFT trainer. And for this trainer, we need to specify what is our model. Our model is stored in this model variable. And what is the tokenizer that it used to tokenize the data while training the model. The tokenizer is also stored in this tokenizer variable. And what is the train data set? The training data set is nothing but the data set that we previously created and stored in this dataset variable. So that's why I'm providing this. And evaluation dataset. So it's an optional. Currently, I'm providing it as none since I haven't created any evaluation dataset. And augments. So here you need to provide whatever the SFT configurations that we previously defined. So that's about creating this. Okay, okay. Trainer. We need to import this. LR scheduler type. So it's an unexpected for this. It's a spelling mistake. SCHEDULER. Now SED is an unexpected parameter. Okay, SEED. It's not SED. Yeah, now the trainer is getting creating with this model as well as this tokenizer with this data set with whatever the SFT configurations that we provided. You can see like a data set field is this text and the batch size is this and gradient accumulation is 4, wrap up steps is 5, number of epochs by default it's 1, so that's why I commented it out, and max steps 30 and learning rate 2e 4 hyphen minus 4, and logging steps are 1, and optimizer that is Adam optimizer we are taking weight decay as 0.01, and linear scheduler type is a linear, LR scheduler type is linear, and seed 3407, and reporting to none currently. So now our trainer got creating. You can see it's loading the tokenizing the text. So now the trainer is getting loading. So after this trainer got loaded, I just want to train my model. You can see my trainer got loaded successfully. So what I want to do is, so this trainer I want to upgrade more like, so whatever the text I have, I don't want the full text. I just want the text of a model response. I just want to take that model response. I don't want a user input, or instructions part is user input and response part is nothing but a model response. I just want to take that response part. So for that, in order to remove the other part, we need to again train only response. Since we need to train only responses, we need to further upgrade this trainer. So I'm just upgrading this trainer by assigning with train on response only method by providing the current trainer and specifying the instruction part. So how the instruction part will be inside our text. So that will be, you can see like a start of turn and user slash n. I'm just copying this. So this is nothing but the instruction part. And what is the response part? The response part will be, okay, start of turn model slash n. So from here the response part got started. So that I'm loading it. Okay, train on responses only we need to import where it is available. It is available in unsloth dot chat templates. We need to import this train on response only, so that it will remove the instruction. You can say it will remove the prompt and it will take only the responses. So don't worry, I'll print the response or you can say output so that we can able to observe what happened. Now, so this trainer got upgraded and loaded. Now I want to see trainer dot train data set of 0. Zeroth value I want to see. So it seems to be numerical. Yeah, we need to tokenize this or we need to decode this using the tokenizer in order to understood. So let's make use of tokenizer dot decode so that we can able to understood this. Okay, I think yeah, IDs. Okay, let's print it. Okay, labels is there. Okay, many fields are there. Labels you have identified as well as attention mass you can able to identify in it. And or let's see what are the parameters that are present by using a dot keys method. Since it's a dictionary, it can able to provide you the all the keys. You can see we have the labels. That means in our trainer related train data set, we have all these training data set. We have all these datas. Like we have input IDs, attention mass, labels, text is there. These three is nothing but initial data set, like whatever the data that we loaded. And after that, using our data processing, we generated these texts, right? Yes. Then input IDs as well as the attention mass as well as the labels got generated after this, nothing but this part. Now what we are expecting is we want to see the input IDs. So let's see the input IDs to see whatever the data that is taking into consideration. So it also in the numerical format. In order to understood it, let's tokenize this data. Let's decode it. Yeah, so you can observe beginning of the sentence user and their input and start of the modal response and model related response. Okay, then I want to see like the label data. So what is the ended or you can say after this conversation, after this was happened, so what are the labels, like what does this label will contain, that I want to see. Okay, so here we need to specify it as labels. Labels out of range. Or let's just print the data. So the reason for this is mm, out of integral value we are getting while tokenizing. Yeah, the reason for that is this, that is -100. The -100 indicates padding token. We can just ignore it, like, so for each token in this labels, let's take it and let's try to decode so only the token using the tokenizer dot decode method. And at the end let's print it with ending equals to empty. That means it will print side by side, except it will be 100 if token is double equals to -100. Then we can assume it as a padding token. Then we just continue the round without printing it. Yeah, you can see whatever the data that it has that got printed from Boolean operations I'm getting. So where is that Boolean operations? I hope it's a response from the model. Yeah, you can see we got only the response from the model. We do not have the user response, like user input we do not have under the labels. That means, so do we remove other data other than responses? Yes. So we only get the responses, so that we observed inside these labels. We only get the model related responses, like Boolean. You have seen, right? That is this. So that is present in this labels. Whereas this input IDs, every conversation, like everything will be there, user as well as the model related response. But after doing this task, train on responses only, what happens is labels got created. Inside that labels, only model related responses are present. So that we have observed here. Since we have trainer is ready, our model is ready inside our trainer, as well as our data set is also ready with only responses inside the labels present in our trainer. Now we can use that trainer dot train method in order to train our model, and training related statistics I want to store it in this training stats variable. I'm just running this. So before it got done, I just open this. So that means the resources you can see here, the resources utilization you can able to observe from here, like the disk utilization, like CPU utilization, RAM utilization. Previously it's 5.6, and totally it is this. And GPU utilization previously utilized is this, and total is this. Disk also this, and total is this free. You can see the statistics also visible to us, like number of GPUs it's utilizing, total number of steps. So whatever the details that we configured inside our trainer configurations, those are reflecting here. This training will take a moment of time. I mean, it will take some time based on the data set size that you provided. Since I provided 10K data set, you can see like 100K rows are there. To train our model, it might take a bit moment of more time. The training was happening here. Yeah, first step was done. How many steps? Yeah, 30 steps that we provided. So 30 steps like that training is happening. And first the training loss will be this, then so it will be a bit increased, but in general it will be decreased. So like that up to I think 10 steps will be happened. So that is the way to train the model. Now you can see system RAM utilization, and so other CPU as well as GPU RAM utilization and disk utilization as well visible to you. So I think 30 out of 30 steps got run successfully. Yeah. So now the training got done successfully. A model training got run successfully. Now what I'm expecting is, first I want to save that model here. You can see unsloth compiled cache will be visible here to you, as well as training checkpoints also visible to you in your Google Drive. And so this is totally free. Whatever the thing that I'm following right now is totally free. This T4 GPU runtime is available for us in this Google Colab for some duration of time. I'm making use of that advantage and training this model using advanced LoRA. It's not LoRA, it's QLoRA. That means quantization is also there, right? QLoRA, we can say it as fine tuning of LLMs and SLMs using advanced SFT techniques, SFT with QLoRA approach, with using unsloth library. So this is how the fine tuning of the models using SFT with that QLoRA approach. The fine tuning got done successfully. Since our model training got completed successfully, and the statistics also we have seen, like so 0 epochs are pending and 30 cycles got completed out of 30 steps. Yeah, and the utilization of RAM, GPU, and disks are clearly visible here. So I'm just closing this. Now I want to check my model working. So what I'm doing is I'm just taking the previous question, like what we have used to verify the model. Verify model is working or not. I'm just copying this and I'll make use of it there. So I'm just dragging it drop. Okay. So let's copy paste there. Let's try to paste it there. Okay. In the model itself, my model is there. And so let's ask the same question right now. After verification got done, we'll save that model to locally to here, and then we'll even try to upload that data in order to Hugging Face in order to make use of inferencing those types of things as well. We will check. So as you can see, we got the response like end of run is this. Okay. So we got Gamma 3 is a family of open source weighted models and MLMs, and so some data is there. That means a model is working perfectly and providing me the response perfectly. Okay, now what I want to do is I want to save this model. I'll show you that how to save that model. To save it locally, that means to save it to here. So just make use of this command. I need to save both a model and tokenizer. So to save the model, just use the model dot save underscore pre-trained. That's it. And provide in which folder you want to save. I want to save in Gamma 3 fine-tuned version, or so Gamma 3 fine-tuned Gamma 3 hyphen V1. So in that folder, let's say I want to save my model. So this command will save the model after running, and so along with that we also need to save the tokenizer as well. To save the tokenizer, for this also the same command pre-trained off, and yeah, that's it. I'm just running this, so it will save the model locally to here. So if you just reload it, you can see Gamma 3 V1 folder got created. Inside this few files will be saved. You can see totally readme.md is there, and so this is regarding just a readme.md file to specify the model related details. And so if you go for this adapter.config, or this model dot save tensors is nothing but your fine tuned data. You can observe that is a 56.91 MB that is visible here. This is nothing but the knowledge that our model got from the training with our data set. We provided 100K rows, right? Yeah. So from this 100K, it will get a weights of size 56.91 MB. So that is the additional knowledge got added to our model due to our fine tuning. And so that is the important one. And regarding other things like chat template, and so those all are nothing but you can say additional requirements. Tensor, tokenizer.model, and tokenizer.json. So these all are related to regarding loading the model as well as the tokenizer. So if you are interested, then just open one by one and just with the data or content which are present in it, but totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So totally 11 files, 11 types of files are 11 files are important with these names. But if the data, you can say the data that we use to train the model got increased, then these dot safe tensor type of files will be increased. So other than 11, 11 plus, you can assume like at least 11 or 11 plus files will be created. So this is nothing but your total model, right? Yes. So that is nothing but your total model. Now I have shown you like how to save the model in locally. Then I'll also show you how to push the model to GitHub as I mean to this Hugging Face as well. So in order to push the model to the Hugging Face, what you require is, so you must require some account. I have my account. I just log in with my account within a moment. Now to save this model to Hugging Face, you can use the command that is a model dot push underscore to underscore hub. There you need to provide the details like so to which account you want to send that account. You can say Hugging Face account name you need to provide, and in which folder you want to push. You can say in which repository you want to push. In Gamma 3 V1, let's say. In that I want to push, and you also need to provide the token because you need to be authorized, right? So f- to authenticate that this account belongs to you, you need to provide the token. So that also you need to specify. And along with the model, I want to push the tokenizer as well. So dot push command I'm using dot to hub, and the same thing like as previously, I need to specify Hugging Face account name as well as the token. The way how to specify this Hugging Face account name as well as this token. Those I've already saved in this, like in my secrets. This Hugging Face account I've already had, and the key, or you can say secret key or token, I already have created. So that you need to create in your Hugging Face account. If you do not have any Hugging Face account, then create one and create some API key and make use of that API key in order to push that, I can say, your model to your Hugging Face account. So this HF key is nothing but my token, and so what I require HF account name I need to get right. User data dot get off. So what is the name that you need to provide here? So that's it. If I just enter this, then so what happens is it will push. So it just push the readme.md. So meanwhile I'll show. I'm just reloading it. Yeah, you can see it got created. I'm just opening it. Under files, what are the files which got pushed? Those will be visible here. So these all are available. Yeah. So yeah, all the data got, or you can say all the files got pushed successfully to that location. Now let's perform inference, or let's use the model that we just push it to the Hugging Face. So for that, so I'll provide you the code, the same code that we used it previously to load a model, that is from unsloth. You need to import this fast model there using this fast model. dot from pre-trained. You need to load your model, or you can say you need to specify your model name. So what's your exact model name? That's nothing but this. This is where my model is loaded. So that's why I'm providing that here. And what is the max sequence length? What is the max sequence length that you want in order to print in the output? Let's say I just want to take a 2048 for now. And so in which format you want to load? I want to load in 4-bit, so that's why I want to put it true. I want to load my model and model in the model variable and tokenizer in the tokenizer variable, and just clicking on enter so that this model got load. This model will load now. So meanwhile it gets loading, I just want to take this code for getting the for providing the input and getting the response. So let it load. So after the model got loaded successfully, so I'll just provide the same input to my model and I'll tokenize it. Then I'll ask my model to generate the response. And finally, I'll see the response back. So it's still running. Yeah. The model related parameter, or you can say model is loaded successfully. Now I'm just running this response. This seems to be misunderstanding of gamma models. Okay, there are families. Okay. So it's just providing me the relevant response related to what is the gamma 3. So why only less output I am getting? The reason is that we just provided 1,000 tokens here in the output. Let's say I am providing 10,000 tokens. Then I'll get a large, or you can say a lot amount of context related output. Huge amount of output I'll get. Compared to previous, now I'll get a lot amount of output. So we can just wait and see. Yeah. Compared to previous response, now the response will be a bit huge. The reason is that we introduced max new tokens got increased to 10,000 from 1,000. So that's why we're getting a lot of size response, huge response. So that's the reason for max response we're getting. So from this we can able to say that what are the things that we have done. Like we installed what are the required dependencies for unsloth. Then we loaded some gamma model, gamma 3b 4 gamma 3 4b IT in a 4-bit, that is quantized model we loaded. After that we loaded our data set and we converted or we standardized that format. After standardizing, what we did is we get the chart template, that is we get this extra one, and then what we did is we just applied the chart template. Then after applying the chart template we get the text. This text field got added. That means both the conversations will be converted into required format of text. After that we created, since we have the trainer that is a data set ready as well as the model is ready, we created a trainer using SFT technique, that is supervised fine tuning trainer we created with the parameters by specifying the text field as the input data set present, and Adam optimizer we require, and the other parameters like a number of epochs, number of steps that we want to train, and learning rate. So other details we specified along with the trainer. In trainer we specified the model configuration, model, what is the model, what is the tokenizer, what is the data set that we use it for training, and what are the SFT configurations that we use it for training. Then we upgraded the available trainer with train only responses. So after doing this, we just check the output, and we have observed these labels. These labels will only contain the responses. So model responses only that will be used for training. So then at the end what we did is we just used this trainer.train method in order to train our model. After training got done successfully, we verified whether our model is responding or not. So after checking that, we even loaded, or you can say we saved the model to this local, you can say to here. So if I want this to this for my system, then you can say you just click on it and just yeah, I think you need to download individually, or you can open this in your Google Drive and make it into zip and download it directly this folder to get this whole gamma model. Then I've shown you like how to upload it to Hugging Face as well, and how to access it from there and get the response from that model from Hugging Face as well. I have shown to you. So this is all about how to fine tune any model, any SLM or LLM using this unsloth library. And for your reference, you can open this Hugging Face related unsloth enterprise related page. Then there you can able to observe some other free notebook resources are available. Like if you want to try Quinn, then that notebook is there along with the code and their explanation. And so GRPO reasoning model is there. Gamma 3. This is what we have taken right now. That is Gamma 3 4B. And Llama 3.2 model is there, 5.4 model is there, Mistral model is there. So these all models fine tuning option is they are providing, like they are showing us in these notebooks, and the performance boosting as well as memory utilization less, like how much it will be saved, those details also mentioned here. And using the method whatever I have shown you, you can able to fine tune any one of the model. So here I think totally 7-10 models are there. You can make use of any one of the model, and you can train it with your domain specific or your client related domain specific knowledge, and you can able to fine tune that model, and you can able to get your own local SLM or LLM, and you can able to fulfill your requirement. So if you observe here, then we implemented this with advanced approach like QLoRA and SFT approach that we followed for fine tuning this model using unsloth. I hope you understood on how to fine tune your SLM or LLM, on top of your domain specific knowledge, and create your own SLM or LLM and host it on top of Hugging Face, or download it to your local directory. I hope you understood that. I hope this video is useful to you and you learned something new from it. If you feel this video is really useful to you, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.